Try the next example. Be very careful as you solve for x, not a symbol, but x. Here is the worked out solution for this example. Note that as you factored and solved for the heart, then replace the heart with the value of 3 to the x power. In one case, 3 to the x power equals 9, which means x must be the value of 2. In the other case, 3 to the x power must equal negative 3. It is impossible to have a power in which the result is a negative answer. 3 to any power can never be negative 3. Therefore, this problem has only one solution at 2. Check by using the store feature of your calculator to verify if this is a true solution to the original problem. Newton's law of heating and cooling is one example of an exponential model application. You are driving on a hot day when your car overheats and stops running. It overheats at 280 degrees Fahrenheit and can be driven again at 230 degrees Fahrenheit. If R is the value given and it is 80 degrees outside, how long in minutes do you have to wait until you can continue driving? Here is the model that we will use. Note the values and what they represent. In our given scenario, we are told that the car has overheated to 280 degrees Fahrenheit. This indicates the current temperature of our vehicle, the starting temperature. The car can be driven again when it is 230 degrees Fahrenheit. That is the final temperature that we must have our vehicle cool down to before we can drive again. The value of R is given to us. Note that the negative is part of the formula. We are told the temperature outside is 80 degrees. That is our surrounding temperature. Note that the surrounding temperature is used in 2 places in the formula. And we need to figure out how long I need to wait. So I'm looking for t, how long in minutes. Note that e is just a value. Plug in the relevant values that we've just identified into the formula. Now, in order to solve for t, which is in the exponent of this exponential equation, I need to simplify inside of the parentheses and undo everything happening on the exponential part. That is, on the e, which is the base. First, subtracting inside of the parentheses, then subtracting off the 80 from both sides. Now I need to divide the 200. Keep both sides as exact as possible. Now that my exponential part is completely isolated, there is little to no way of writing both sides of the equation with the same base. Therefore, we will apply a log to both sides of the equation. Again, choose a log that makes sense in the context of our problem to help us solve this equation best. I can use either the common log or the natural log. Since my base is e, I'll apply the natural log to both sides. Use log properties to drop the exponent down to the front. Note that because we use natural log of e is the value of 1. So I really already have the t without a natural log on the other side. I just need to divide both sides by the r value that we have, the negative 0.0048 from both sides. Now that t is completely isolated, now we may pick up our calculator and carefully type this in to approximate the value of t rounded to 3 decimals. You must wait approximately 59.934 minutes before you can continue driving. Try the next problem on your own. Here is the solution to this problem. It will take about 68.148 minutes for the water to cool. Worked out examples of extra practice are posted on Haiku. Complete the rest of the problems in this packet.